Okay, I'm hoping to explain how we know which elements are going to be which ion charges. Okay, so I have included the periodic table here, and that's pretty much all you need once you know the trick. Um, and we all know that the atomic number is the number of protons, and for a neutral atom, the number of electrons should equal the same number of protons. When we create ions, the number of electrons either is going to outnumber the protons or the protons are going to outnumber the electrons, and that's why we get the charge. But to find the number of electrons in the outer shell is important because atoms only care if their shell is full or not. Okay, so that's kind of interesting. Um, a guy named Bohr sort of figured out that the electron energy levels follow this pattern. Two go in the first shell, and eight go into the second, no more, and up to 8 or 18, depending if you want to get fancy, go in the third. We'll say up to eight go in the third. Okay, so up to two in the first, eight in the second, up to eight in the third. So the periodic table is numbered so that you have first hydrogen and it's only one proton, therefore it only has one electron. And it's just hanging out in that first orbital. The first orbital always fills out first, and he's not happy because it kind of looks like this. All right. It's nucleus, got the protons and neutrons, and then there's that little one orbital. And it would rather have no electrons in its shell, in that level, energy level that the electrons normally live in. I would rather have nothing if it's not going to be full. So hydrogen has two options. It could gain an electron from some other atom, or it could just lose an electron. And generally speaking, it likes to lose. It's easier to lose things than it is to gain. Like it's easier for me to lose my car keys than it is to gain car keys. So hydrogen just loses one and then still has that one proton in its nucleus. And since it still has that one proton but no electrons, its charge becomes a +1. Okay? So here, on your periodic table, maybe you can label that hydrogen likes to be +1. Next one, helium. Helium has two protons, so therefore it would have two electrons. And they go in that first energy orbital, we like to call it, or shell, and he's happy. He's chilling. He doesn't need to do anything. He's full. So he's usually non reactive, and that's why you can inhale helium and nothing really happens. It's just element helium. It's going to sit there. But when we get to lithium, it's a different deal. You kind of easily see here, lithium has three electrons. The first two go in the first shell, which is wonderful. But then that third one's hanging out all by himself. Kind of like hydrogen, you know? Only this time, he would have to gain 8 to be full. I don't know if you've noticed here, but these rows kind of correspond to the number of electrons in each shell that it can hold. Total, 2 in the first, and then we end that row there, and then 8 in the second. We end that row with neon. So lithium could either be like neon, which means he'd have to find 7 electrons from somewhere, or he could just lose that one electron and become more like helium. So yeah, that's what he likes to do, and he likes to become a +1 charge ion. Okay. Um, Beryllium, it's got 4 electrons, and those 4 electrons, 2 in the first, hang out there, and they're happy, and they're okay. 2 in the second, now he's 6 away. 1, 2, 3, 4, 5, 6 from having 8, or you can just remember it's 8. So he likes to lose 2. If you lose 2 negative charges, beryllium still has those 4 protons, but only 2 electrons in that original inner shell. And so it becomes a +2. By the way, this outer shell, we like to call the valence shell. That's all that really counts, since the inner shells are going to be full and the outer shells are going to be what's closest to other atoms. It's going to be more reactive. It's also going to be what needs to gain or lose. So all we kind of really care about, actually. Boron's got 5, so it's 3 hanging out there, still closer to losing those 3 than it is to gaining 5. And the reason why I'm arrowing, because you can sort of count. You can say, okay, 1, 2, 3, 4, 5, and then you look like neon. Well, that's exhausting. 1, 2, 3, and then you can look like helium. And so he becomes a +3 ion. Okay, so that's why this column I don't know if you can see that trend tends to be a +3, and you can label your periodic table like that. All right. This next one is a little bit weird because you have 4 that you need to either gain, because you have 4, you need 4 more, or you want to lose those 4. Probably easier to lose, but I'll tell you, in real life, these guys, they just like to bond and share. Sorry, they bond with covalent bonds that are shared atoms, instead of gaining or losing electrons. But that's okay. If it had to be an ion, it could gain 4 electrons and be -4, or lose 4 electrons and be +4. Because, carbon still has its 6 protons, and then it would only have, either 2 electrons, or would have, if it had lost all those, and then it would be +4, which is probably more likely to lose those 4. But that's okay. It could also gain 4, and then would have 10 electrons and still have 6 protons. Okay. So silicon, you can see it does the same thing as 2 electrons in the first shell, 8 in the second, that's 10. The last 4 go in the outer, so its outer shell looks the same as the elements above it, and you'll find below it on the periodic table, all the columns are the same. Nitrogen is where we kind of tip the scales to closer to gaining electrons to look full, to be full and look like a noble gas. Or, maybe it could share electrons too, and I feel like he has more. But see, if nitrogen was going to become an ion, it would gain those 3, would gain 3 negative charges, so it would be more negative by 3, and it would have a total overall charge of -3. And oxygen is going to do 2. It's missing 2, so it's going to gain 2. So we're going to make sure that oxygen, if it becomes an ion, it will be an anion. It'll be -2. And we got the fluorine and that last column. Man, they're so close to having a full shell. They just really badly want an electron. So they're going to pull off an electron from, by the way, they pull it off from another atom, and that becomes more positively charged. So yeah, they're going to pull one off. Maybe you could pull one off a lithium that already wanted to give him one. Or maybe you could pull one of beryllium's, and then another fluorine would need to pull off that other one. So that's where those electrons are coming from, is another atom that's donating. So yeah, fluorine and a chlorine that looks exactly like it is going to be a -1. So you can see all of these in the column. If they become an ion, generally speaking, that's what they're going to become. The weirdness happens at the transition metals, where there's like these extra sort of electrons in this d orbital, and then it can do weird things and promote electrons. So we like to just use Roman numerals to express what kind of cation these transition elements are going to be. So it's going to be positively charged, and these guys are going to be positively charged too, but we won't know what they are until you're told what they are, because they actually can transition between 1 or 2, maybe, maybe they don't, but they could. All right, so hopefully that gets you an idea on how to find the ions of the elements when we ask you, or the ions that could form on your test. Remember, the noble gases, they do not like to form ions. If they formed an ion, they'd have to lose, like, helium would have to lose 2 electrons, because that's all it could do. I mean, you're not going to want to partially fill a shell. Neon probably lose 8. That doesn't usually happen. Maybe down here in the bottom it could happen. It's just some less stable elements. All right, thank you for joining us, and good luck on your assignment. Okay, let me know if you have some issues, and we'll hopefully take care of